Welcome intellectuals to our today's wonderful tutorial. So in our today's lesson, we are going to revise on this is chemistry 2024 past paper question 6. So this question is on Arrhenius equation. So we talked about Arrhenius equation. This is just a revision. Like I told you, we are just revising. So question 6, the question leads from the plot of Rn K against 1 over temperature, that is there. Slope was found to have a gradient of -1 of -9.1 times 10 to the power 3 per Kelvin. Calculate the energy of activation, that is just the activation energy for the reaction that produces at a plot. You have been given the gas constant to be 8.314. 2. Given that the intercept of the plots on y-axis is -0.7, work out the Arrhenius constant A for the reaction that produces the plot above. Okay, so just a quick review on Arrhenius equation. I thought that the Arrhenius equation it just tells us about how the reaction now depends on the change in temperature, also the activation energy. So the formula for the Arrhenius equation is given by the Arrhenius constant. So the rate constant is given by the Arrhenius constant, which is A there, then E, which is just the exponential there, the natural log A there, the activation energy over RT. I know most of you, more especially for you guys who we were together during the holiday, you can know this, you can appreciate this. So now, what have we been taught? We have been taught that the plot is between Rn K and 1 over T. So what we are going to do to the equation is this. We are going to introduce Rn to both sides. So the equation, so we are going to introduce Rn here, also Rn here. But what I want you to see, guys, that to these parts we have A. Okay, let me divide these parts. We had A and e to the power EA over RT. What, guys, do you understand about the natural log? So whenever you have a natural log, for example, Rn A times B, it's the same as having Rn A, because we are multiplying, going to have Rn A plus Rn B. This is what we were doing in mathematics. So this expression is also going to be written as Rn K is going to be equal to Rn A plus Rn E, now raised to the power EART. Okay, so what's next? Can we do to the equation? We're going to say Rn K is equal to Rn A. So the natural log allows us to bring the exponent here. So we're going to have minus EA over RT. No, not the new concept. I can't waste much of my time explaining this. This is what we are doing. Okay, we all know that Rn E is just 1. So we're going to have our Rn K to be equal to Rn A minus EA over RT. Okay, so now I'm going to bring this. I'm going to say Rn K is going to be equal to, I'm going to start with this, which is negative EA over RT, then plus Rn A. Now this expression, this EA over RT, can also be written as EA, which is activation energy, over R, then multiplied by 1 over T. As you can see, 1 times EA is just T, activation energy, which is EA there, then R times T just T, RT. So we just, this expression and this are one and the same. So we are going to write as Rn K is going to be equal to negative activation energy there over R, then multiplied by 1 over the temperature there plus Rn A. So there is something that I want you guys to understand when the equation lead at this point. I'm going to write the equation of a straight line, which we already know. The equation of the straight line is given by y is equal to mx plus c. Okay. So that means the value of y is ln k. What is the value of x? X is 1 over t. And that's why you guys remember that when you are plotting a graph, you always have x versus y. Okay, this is how you have the graph is between the x-axis and the y-axis. So that's why in the question they mentioned to say that the graph was between ln k and 1 over t, as you can see here. Ln k and 1 over t. It is from this formula they get that. Okay, after that I want you to see this m. This m shows the gradient or a slope. Okay, so the m represents the slope, the gradient, which is equal to ea, it is activation energy over r. And this c is the y-intercept. Take note of all this that I'm writing here. Y-intercept. So in this case, our y-intercept is Rn A. So with this information, we can find the what? The activation energy, because the first question is to find the activation energy that produces this slope. Okay, this was the slope that we are given. This is the gradient. So we are asked to find the activation energy. So you can see now this is the formula you'll be using whenever you are asked to find the slope. Okay, so you say m is equal to negative activation energy over r. Okay, the slope has been given to be a negative 9.1 times 10 to the power k times 10 to the power 3. Negative 9.1 times 10 to the power 3. Okay, what else have we been given? We have been given the gas constant is 8.14, 8.31. Okay, 8.314. So you can find the activation energy very simple. Okay, so what you do, you say you cross multiply. So activation energy is going to be equal to the slope multiplied by the gas constant. To get rid of the negative, meaning we put negative, we multiply the whole expression by negative 1. So this is negative, is going to become positive. Then this is the one which is going to become negative mr. So you can say the activation energy is going to be equal to negative multiplied by m, which is negative 9.1 times 10 to the power 3. Okay, we multiply by the gas constant, which is actually 8.314. What is the activation energy? The activation energy will be no other than it's my calculator. So the activation energy is going to be equal to 75. Okay, we have 657. Okay, 657. We have joule per mole. Okay, since this number is so big, we can convert into kilojoule, but we can just end it on here. But if you want, we can convert it into kilojoules. Converting into kilojoules we have to divide by 1000 so that our activation energy can be equal to 75 point, if you want you can say 0.657 kilojoules per mole. Okay, kilojoules per mole. If you want you can hand your answer A or your answer A. So the most important thing here to take note of is the slope. Know the slope so that you may be it will be easy for you guys to find out the activation energy. So now the question number 2 is to work out the Arrhenius constant A. Okay, the Arrhenius constant A, when you are given that the intercept is negative 0.7. Okay, what I was telling you guys, I was telling you that the intercept is given by ring A. So we say the intercept is given by ring A, and you have been told that the intercept is negative 0.7 is equal to ring A. How do we get rid of ring A? We are going to say, we're going to introduce, I was telling you guys to say that when you have an expression like this, you have to say, for example, x is equal to e to the power 2. The way we used to bring this e down, 2 down, we used to introduce ring everywhere, right? Yes, so that we may have ring x is equal to 2, then ring here will go because it is 1. So this expression came from this same part. So we're going to introduce ring, it's more like we're going to introduce ring everywhere, the e everywhere. So we're going to have e to the power negative 0.7. So once we introduce that e is going to cancel this natural log because ring here is just what? It's just 1. So we're going to have a is equal to e to the power negative 0.7. And our value of a is going to be equal to 0.4966. Very simple. So this is how you find all the needed. So just know how I derived this formula from the Arrhenius equation, how I came up about this formula step by step. You can watch the video if you have missed it. But there are a number of formulas on the Arrhenius equation. We have the formula on how we can find the activation energy using 2 temperatures, and also on how we can find the same temperatures, different temperatures using the same activation energy, and if the higher temperature has been given. So those videos are there on my channel, but you can't watch them unless you are registered. So the best way you can do, guys, is to register under our tuitions at a fee of only 70 kwacha per course. Okay, so this is just chemistry. Also of our tuitions in all the courses. We have chemistry, we have biology, we have physics, also mathematics. So just register now, inbox me, just only 70 kwacha per course. So thank you for watching, guys. See you in the next session. Don't forget to share.